Today, we are learning how to find the area of a parallelogram using vectors. When two adjacent sides of a parallelogram are represented by two vectors, called vector A and vector B, the area of the parallelogram is found using the cross product of these two vectors. The cross product of vector A and vector B gives a new vector. This new vector is perpendicular to the plane of the parallelogram. Because it has both direction and magnitude, it is called the vector area. However, the actual area of the parallelogram is only the magnitude of this cross product, so the area is equal to the magnitude of vector A cross vector B. To calculate the cross product, we usually use the determinant method. If vector A has components A1, A2, and A3, and vector B has components B1, B2, and B3, then we arrange the unit vectors I hat, j hat, and k hat in the first row. The components of vector A go in the second row, and the components of vector B go in the third row. Then we expand this determinant along the first row to get the cross product. The solving strategy is simple. First, write the two-side vectors clearly. Second, calculate vector A cross vector B using determinant expansion. Third, find the magnitude of the cross product. Finally, that magnitude is the area of the parallelogram. Let's work through an example. Suppose vector A is I hat minus 2j hat plus 3k hat, and vector B is 2I hat plus j hat minus 4k hat. To find the area of the parallelogram formed by these vectors, we first find their cross product. We set up the determinant with I hat, j hat, and k hat in the first row. The components of vector A are 1, negative 2, and 3, so they go in the second row. The components of vector B are 2, 1, and negative 4, so they go in the third row. The j hat component is handled with a minus sign, giving negative of negative 4 minus 6. The k hat component becomes 1 plus 4. After simplifying, vector A cross vector B is 5I hat plus 10j hat plus 5k hat. This cross product is the vector area of the parallelogram, but the required area is the magnitude of this vector. To find the magnitude, we square each component, add the squares, and then take the square root. So the area is the square root of 5 squared plus 10 squared plus 5 squared. This becomes the square root of 25 plus 100 plus 25. Adding these values gives the square root of 150. Simplifying this gives 5 root 6. Therefore, the area of the parallelogram formed by the two given vectors is 5 root 6 square units. The key idea to remember is that the cross product gives the vector area, and the magnitude of that vector gives the actual scalar area. For this example, the final area is 5 root 6 square units.